Hi, so my name is Robert Kaufman, and today I will be introducing you to the concept of pointers. All right, so every object, um, any type of variable you have is going to have a quote unquote place in memory, and we call this an address. You can access the address of an object by placing an ampersand or an and symbol before the variable name that you're trying to find the address of. Um, And there are also these special objects called pointers, which can hold an address on another object. It's a variable type that can hold an address. So when you're declaring a pointer, you have to declare a pointer of a specific type. All right, so each object type has its own associated pointer type. For instance, there are int pointers or there are char pointers. There are also pointers for any other object that you declare, like any sort of struct or class. Um, Pointers are declared in the same way as a regular variable, but you're just going to add an asterisk to the variable type. As you can see, I have like an int star, and that will be an integer pointer. And once a pointer is declared, you cannot change the type of information it holds. So it can only point to an integer or a char, whatever you declare it to be. On this right side here, you can see that I define an integer, and then I define an integer pointer here, call it pointer1. I also define this char. We'll see that later. So I tell this pointer one to hold the address of variable one, and then I don't do anything with it, which is bad practice, but ignore that for right now. I also tell it to hold the integer of variable two, but this causes a compiler error because pointer one is an integer pointer. But variable two is a char, so it cannot hold that data type, and you'll get a compiler error. All right, so when you want to actually access the data that the pointer is pointing to, you have to do what's called dereference the pointer. And when you want to dereference the pointer, you confusingly also have to use the asterisk, the star. And this time you're going to put it before the variable. So in this example over here on the right, same thing where I initialize pointer one to be the address of variable one. And you can see variable one has the value 3 here. So this dereference here is going to look at the address at pointer one. It's going to jump to that address. It's going to grab the data there, and it's going to return that. So this will print 3 here. All right, so just like any other variable, uninitialized pointers are bad. And yeah, in order for them to be useful, you need to set them to something. So they're always going to contain something, but it's not explicitly, if you don't explicitly set it to something, it's just going to have some random data, which is not good. And if you do reference a pointer that's not initialized, you could have undefined behavior, which is really bad. And the scary part about this is that a compiler would generally not catch this. So the last topic I want to cover are null pointers. A null pointer has a value of 0, which means that it's pointing at the address of 0. And since nothing is actually allowed to be at address 0, you're not actually allowed to dereference a null pointer. And if you try to dereference a null pointer, you're going to get a runtime error and your program will crash. So you can set any type of pointer to be a null pointer, like any variable type pointer. You can set an int pointer or a char pointer or any struct or class to be a null pointer. So it's kind of special in that way. And they're initialized with the keyword null pointer, kind of intuitively, just in this way at the bottom here. So to recap, pointers are data types that hold addresses of other data types. They're both declared and dereferenced with the asterisk key. And just like other variables, they need to be initialized or they will have undefined behaviors, which is, as we know, quite bad. And null pointers are pointers that cannot be dereferenced and hold essentially no data.